friction between block B and ground would be mu into normal reaction. The normal reaction would be 200 plus 100 minus 20. The vertical component of tension will be is also there. So normal reaction plus the vertical component of tension together is going to be 300, balancing the mg. So so this would come out as 70 Newton. Now the total force that you have to apply externally would be 70 plus 20, the sum of both the friction forces. So the minimum, that is the minimum amount of force that one has to apply for the block B to slip beneath A. Okay, now let's see another familiar situation that we have seen in Newton's second law of motion. Suppose this is the arrangement. There are three pulleys, a block of mass m, and a man is standing on that block, and the mass of the man, suppose be capital M. Now the question is, what is the minimum amount of tension that the man has to apply on the rope such that, or let's see, what is the maximum amount of force that the man has to apply on the rope such that the mass does not move. The block on which the man is standing does not move. Pretty simple, straightforward. So it shouldn't take more than 60 seconds. Quickly, get your answer. Minimum amount of force that man has to apply will come out as capital M plus small m into G into mu upon 1 plus mu. And it's not difficult, it's pretty damn easy. You see that whatever force a man would be applying, that will be equal to tension, and that would be the tension here as well. So tension is the force that will be pulling the block forward. So if you see that tension, and the only force this tension has to overcome is friction, and friction is mu into normal reaction, and normal reaction would be capital Mg plus small mg minus t. Okay, because if you see the man on the block, if you take the man on the block as a system, the net force downward is this, the upward force is this, the difference of that would be the normal reaction. So from here you get T. Okay, so that was easy. Now let's consider an interesting situation. This is suppose B, the mass is supposed 20 kg. This is suppose block A, the mass is 10 kg. Block A is resting on block B. The coefficient of friction between A and B is suppose 0.3. And this surface is smooth. Okay, now a force, constant force of 120 Newton is being applied horizontally on block A, and a variable force F is being applied horizontally on block B. Now I'm going to give you one by one different situations, and in those situations you're going to give me the answers as would be required by the situation. The first thing is, the first case, if suppose F is 0, there is no force being applied on block B, then what would be the acceleration of each block A and B, and what will be the direction of friction forces acting on A and B? Fine, you have to work with me with this. So get your answer. What will be the acceleration of A and B? You can do it orally, it's pretty damn simple. And what will be the direction of friction forces acting on A and B? Now, the first thing is the external force is 120 Newton and the limiting friction force here is going to come out as 30 Newton, considerably less than 120 Newton. So there's a high chance that there would be slipping between A and B. So the max, if you see the FBD of block B, then the only horizontal force acting on block B is friction force. So whatever acceleration this block B is going to have, that's only because of friction force. And the maximum acceleration that this block B can have, the maximum acceleration of B can be maximum force, which is the limiting friction upon mass. That will come out as 1.5 meter per second square. Maximum friction. Now, to check whether they are going to move together or they're going to be slipping between A and B, how do you check? You check like this. Suppose there is no slipping, then A and B are moving together, and if A and B are moving together and you take A and B as your system, then the friction force becomes the internal force. Net friction force is 0 because whatever the value of the friction force is on B, on A it's just opposite and same in magnitude, so it cancels out. So the only external force is 120 Newton, net force is 120, and net mass is 30. So acceleration comes out as 4 meter per second square if A and B are moving together. But from here we can see that the maximum acceleration that B can have is only 1.5 meter per second square. This means that A and B are not moving together. They are slipping, and if they are slipping, then the maximum friction is acting between them, which is whose value would be 30 Newton. So from here you can say that the acceleration of B will be 1.5 meters square and acceleration of A 120 in forward direction, 30 in backward direction, 90 Newton. So the acceleration of A will be 9 meter per second square. The friction is kinetic friction, and if mu, only one value of mu is given, then take the mu as same for static friction and same for kinetic friction, because the difference is very marginal.